All right, well, welcome everyone to 24 Hours of PASS Summit Preview Edition. We're excited you could join us today for Peter Meyer's session, Past to Future, Self-Service Forecasting with Microsoft BI. This 24 Hours of PASS event consists of 24 consecutive live webcasts. Sessions will be recorded and posted online soon after the event. My name is Aaron Nelson. I'm a SQL Server MVP and consultant. And I have a few quick introduction slides before I hand the reins over to Peter. He will speak for 40 to 45 minutes, and then move on to Q&A, where you can ask any questions you may have. If you're having any issues, type your issues into the questions pane, and someone will assist you. To maximize your screen, use the zoom located at the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your question to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. Now I'd like to take a minute to say thank you to our sponsors. The staging of 24 Hours of PASS would not be possible without their support and dedication. They are the reason this event is available free of charge. Thank you to Microsoft and Dell Software. Next, as you may know, this 24 Hours of PASS is a preview of PASS Summit 2014, the largest conference for SQL Server and BI professionals. With over 5,000 attendees representing 2,000 companies from 52 countries, Summit is a time to share, connect, and learn with your peers and industry partners. PASS Summit is not only a week of intense learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts like Peter and myself. Taking place in Seattle, Washington from November 4th through the 7th, PASS Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 Hours of PASS sessions provide a mere glimpse of what you can expect from PASS Summit. Find out more at passsummit.com, and if you register by September 26th using discount code 24HOP14, you'll get $200 off the registration fee. And now, I'd like to present Peter Myers, our speaker of the hour. Peter's been working with databases since 1997 and has been a SQL Server MVP since 2007.
Well, thank you, Aaron. So as Aaron introduced, this session is about past to future. It's about forecasting, and in particular self-service forecasting, and how this can be achieved by using Microsoft Business Intelligence. There are in fact several topics that we'll be working through here. They will involve us understanding what we can do and how we can achieve forecasting with the Excel add-ins. These have been available for some time as a free download from Microsoft to allow you in originally Excel 2007 and now supported for Excel 2010 and 2013 to perform data mining activities directly within the workbook based on local data. We're going to explore a newer capability delivered as a self-service experience to information workers with Power View forecasting. This is achieved through the Power BI site. And then we're going to bring the two together and say, well, what are the comparisons here? Which would fit at a particular activity that you have? So the takeaways of this session will be to understand capabilities and features of both the Excel data mining add-ins and the Office 365 Power View forecasting. Here's the outline for this session. Let's begin with the very fundamentals. There are no expectations that you have a background in forecasting, so let's introduce the fundamentals here, and then we can talk more sensibly about the self-service capabilities with the Excel mining add-ins and the Power View in Office 365. We'll wrap up with that summary consisting of a summary of capabilities, a comparison of the capabilities, and some resources to help you moving forward to explore this for yourself. So I think the best way to start this presentation is to talk about the history of forecasting. Why is there a need for us to even forecast? And this is somewhat humorous. It's one of my favorite comic authors. He's in fact a Melbourne-based comic guy for the local newspaper here. Since the dawn of time itself, cavemen here have always pondered, what's the future have in hold? There's this need to understand where we could be going. And so in more recent times, and perhaps more applicable to business, you might find business people engaging with clairvoyance to understand, what could be the competitive landscape in the future, what could be the stock market price, and so on. Even more recently, we see Octopus here predicting the outcome of a World Cup. And again, the need for us to know who is going to be the likely winner of the outcome of a game. All right, well, these techniques are somewhat questionable. We're here to talk about good data science and how we can use it to drive reliable forecasting activities. So let's begin here with the definition that time series forecasting is about producing data mining models that are there to predict future values based on previously observed values. So if I provided you here a line chart that showed us sales achieved across 3 years, and note the cycle here, and with the trend of growth, we can see there's this peak somewhere in the middle of the year, and then a drop off 6 months later, and then a recycle of that pattern. That we can train via an algorithm a model to detect a pattern here, and then use it for the purpose of prediction to understand what the sales could be for the next 12 months. So how do we achieve this? We achieve this by defining a time series mining model. And if you have a background in data mining, it might be of interest to note that training a time series mining model requires a relatively small data set. Some mining tasks require millions and millions of data rows to input and detect a pattern, whereas here it could be simply the sales achieved by month for the past 3 years, 36 data points. Usually you'll want at least 4 cycles, and the cycles would depend on what you're analyzing. It could be weekly data, monthly, yearly. And so at a minimum we would say 2 at least, better if you've got 3, but certainly 4 is a good volume of data that represents a cycle across time. Your models are sensitive to correct configuration or the detection of periodicity. So periodicity really is a fancy word for the seasonality or the repetition of a cycle. And so I think I'll prefer the word seasonality when talking with an information worker, is that you want data that has a definite pattern that continues or repeats like an annual pattern of months. The model lifetime can be ephemeral. By this we mean short-lived. Having produced the model and having predicted from it, it may then become obsolete. We would then produce an entirely new model as we moved forward based on the data that we've recently observed. Important to note that outliers can severely impact on the quality of the forecast. So if you have values that are abnormal, they will likely impact, and so it may well be a good idea to identify them and to fix them. And I'll show you a demonstration that deals with this very shortly. The reliability of the model. So how do we trust the forecasts that this model delivers? And one measure of this is to statistically measure the accuracy via deviations. So I'll take you back perhaps to your early day in mathematics and statistics, and that we learned that with normal distribution you have an average standard deviation describes the spread of data, and one standard deviation from the average would tell us that values are within 68%. So a prediction could be measured in terms of how likely would it be. If you were looking for a 95% chance that your prediction was reliable, you'd be asking for 2 standard deviations against a mean. So we'll look at some techniques shortly that allow us to query and then determine just how reliable the model would be. Of course, you don't want to find yourself in a situation of predicting values on a completely unreliable model and then wondering later why we were so off track. So the point here is that high deviations should be detected and could be addressed by tuning the model or by adjusting those outliers. Next is the discussion about the forecasting life cycle. So typically when working with data mining, this requires advanced skills and experience. There's a number of phases that we work through in the delivery of a mining solution. The first would be the acquisition of data. Accessing, cleansing, transforming and shaping historic data to ensure it's clean and reliable and representative. We would then select an appropriate forecasting algorithm. So for us, that would be a time series algorithm. We could configure parameters to control or govern the behavior of what the algorithm does. One such parameter could be the periodicity. What is the repeating number of rows that represent a cycle? So you can provide all sorts of information that help tune the behavior of the algorithm. Having trained a model, the next thing would be to measure the accuracy. And then having measured this and established that it is reliable, you could deploy, secure it, and make it available for use. So I think, as you'll appreciate, it requires a fair degree of expertise and skill to implement this type of solution. And yet that's not really the focus of what we're here to talk about. Certainly we're here to enable forecasting, but specifically self-service forecasting. And I think we need to remind ourselves about the audience that would be looking for the forecasting activity. And I think this slide's quite cute in the sense that we've got this child that needs the support, big obvious buttons to achieve defined outcomes. And that's certainly the experience that Microsoft are delivering to the information worker. It should enable exploration, it should be iterative, not necessarily in any specific order, and this is what we're about to explain in this session. What are Microsoft providing to enable self-service forecasting? The first topic, and then from a historic perspective, the topic that first came on the scene with Microsoft BI was the SQL Server data mining add-ins. So there are in fact two add-ins when you install them. Free download from Microsoft. When you install them, you have the table analysis tools and the client tools. Today these are supported for Excel 2010 and Excel 2013, and both add-ins require a connection to analysis services. That would mean somewhere on your network there's an instance of analysis services, it's in multidimensional and data mining mode, and it has been configured by an administrator to enable connections and for session mining models to take place. Now when you download and install this, there's actually a very good guide during setup that will enable you to either let the administrator know or to perform the administrative tasks as part of the setup. But it's reasonably straightforward. Now, under the covers, when it uses analysis services to perform the mining, let's talk about the algorithm that's being used here. Its official name is the Microsoft Time Series algorithm, and it was first delivered in Analysis Services 2005. Now, in the SQL Server 2008 release, the update to this algorithm meant that there's really two algorithms under the covers at work. There's the ARTXP and the ARIMA. Now, the ARTXP is autoregressive trees with cross prediction. The ARIMA is more concerned with a moving average, an integrated moving average. What you're getting with these two algorithms when they're blended together, which by the way is the default behavior, the ARTXP is really tuned and optimized for short-term predictions. What it will do is look at the pattern of the observed data and it will produce the next 1, 2, 3, 4 steps. Whereas ARIMA is more concerned with a stable longer-term forecast. And so it will look at integrated moving averages to produce a stable longer term. And so the best of both worlds come together here. By blending the two algorithms, you get a more reliable and accurate short-term prediction, and if you wish to go into longer-term projections, you get stability with ARIMA. The algorithm detects trends, it can use them to predict future steps in a time series, and this is what the table analysis tools is using when you're using the forecast capability. So I'll just point out here on the ribbon, excuse me, I'm highlighting the wrong one, you have the forecast capability. What you see here is an analyze contextual ribbon that when you have an Excel table in focus and the add-in has been installed, the analyze ribbon will surface and it will then highlight to you that you have these 7 tools to perform mining on the data. The one of interest to us today, of course, is the forecast capability. Now this provides an extremely easy to use interface that leverages analysis services data mining under the covers to perform analysis on spreadsheet data. So my first demonstration will be forecasting with the table analysis tools. The forecasting scenario that I have here in this session is about forecasting chocolate ice cream sales. And so before me here I have this set of data, 4 columns, month in column A, vanilla, strawberry, chocolate, and then I have 36 data points representing the sales from July 2011 right through to June 2014. First of all, the data is not in the format of an Excel table. So on the Insert Ribbon tab, I then define that this will become a table. Yes, the table have header rows. And now that it's a table, do you notice automatically that I've got the Table Analysis Tools ribbon exposing that there is action that I can perform against the table? Now the first thing that I need to do though is to establish a connection with the Analysis Services instance. There is no data mining engine on the desktop. We're going to establish this connection, and in this instance I'll be connecting to the local host, and the administrator on this machine has created a database called DM@DB. For this to work, I must have privileges to connect to this database, which indeed I do, and the administrator must have set that the instance property, it's called Allow Session Mining Models. By default, this is set to false. The administrator must have set that to true. With all of this in place, I can simply click on the forecast command on the ribbon, and then I have this reasonably straightforward interface. The forecast tool performs forecasting on a selected table. Couldn't be simpler. It has automatically selected the 3 flavors of ice cream, and it hasn't selected month because it recognizes that this is really the time key. The next thing that I'll configure will be the number of steps to forecast. So I'll increase this from the default of 5 to 6, and then I have options to specify where is the timestamp, that's in the month column, and then the periodicity of data. Now even if an information worker didn't know what periodicity meant, and I would gamble that most wouldn't, I think they would work out from the available drop-down list items that monthly represents the data that they have here. So with this reasonably straightforward configuration, the selection of the different products as different time series, and then the number of units to forecast and some options about time. When I click Run, the work that's going on here is that it's communicating with Analysis Services. It is, let me take you back to the table, it is creating a temporary mining session model. It is uploading the data from the spreadsheet to the server. It is performing the mining, and then it queries to bring back, as you'll see now appended at the bottom of the table, the next 6 prediction values. All right, so what I'll choose to do here is copy down the time range to see that we've now got projection into December 2014. Now the other thing that it does is it inserts a chart, and the Forecast Report tab here shows the chart, providing me in solid line the observed values, and then in the dashed line here, as you'll see for chocolate, we see the projections. Now something might stand out as a little unusual when you look at this data, and I've deliberately done this to highlight the fact that something is odd here. That we've got this reasonably nice pattern that chocolate, in fact all ice cream sales, peak within the middle of the year. For the Northern Hemisphere, this would be the summer months, and higher demand for ice cream sales as you'd expect. But here, sometime in June 2013, something happened to chocolate. And perhaps with our domain knowledge and understanding of this business, we would say, oh, I remember, there was actually a shortage of cocoa bean. It wasn't that we couldn't sell it, it was that we had a disruption to supply, which meant that we couldn't deliver to customers. So the fact is, this type of anomaly can have a severe impact on the pattern detection and therefore the quality of prediction that comes out of the model. So what I'm going to do is delete this sheet. We're going to return to the sales history that I have here, and I can simply delete the 6 rows that were appended to the table. And that basically resets me back to where I was before. And then I identify and in fact locate that it's this cell here that I'm going to mark with a style of bad, and just highlight here that in June 2013, this 115 is a little bit odd, and we're going to address this by updating it with a more reasonable value should have we had the supply of cocoa bean. So the technique I will use here, and it will depend on circumstance, but by selecting the cells on either side, you'll notice down here that Excel provides me the average, of which would be 563. So how about I use the average of 563 to address that anomaly. I'm going to update the style to good now, but I'll keep it shaded because it tells me that I'm actually manipulating the data for the purpose of providing a reliable forecast. And then I'm going to return to the forecasting activity on the Analyze ribbon and apply the same forecast. Let's forecast the next 6 steps. And the periodicity is monthly. And so now you can see in the forecast result this very definite pattern and hopefully a more reliable prediction for chocolate. An interesting thing to point out at what's going on here when you're using this algorithm is it does look for cross-prediction capabilities. Now, this is in fact a feature available only on the Enterprise or the Business Intelligence editions of SQL Server, but it is a unique offering with the time series forecasting with analysis services, and that is that it can detect across the series. For example, if strawberry increases, it might detect the pattern that chocolate decreases. A substitution is taking place. And so not only will it look for a pattern within its own time series, but will look for cross-prediction across the series. This is actually a cool capability. So let me delete to clean up because I have other activities to demonstrate, but that is the demonstration on how to use the table analysis tools to perform forecasting. It's reasonably straightforward. Just have well prepared at least 2 to 3 cycles of data in a table in Excel, connect to analysis services, and then have it perform the mining and produce query results in the form of a chart and new rows in your table. Now the second add-in is the client tools, and this one offers a full data mining model development lifecycle experience within Excel. So arguably this may not be an information worker activity, but it certainly could be described as self-service, perhaps to an analyst or even a data scientist. It has been designed to work through the entire data mining process, from data acquisition right through to the application via querying to bring back results within Excel. It also includes model management options that allow you to process, delete, and manage the models on the server. So let's take a look at it in demonstration, switching back to the same workbook with the objective of continuing to forecast chocolate sales. This time I'm going to switch to the data mining ribbon on the tab. Okay, so this is the interface for the second add-in known as the client tools. You'll notice already in the connection that we continue to connect to the DM add-ins database. There's also this tracing capability. Let me just open the trace to show you that here is a history of all of the commands that have been sent to the server. All right, so the very first command here was to create this session mining structure. And there we see the 3 flavors of ice cream, vanilla, strawberry, chocolate. The next command was to define a model. And you can see here the use of the time series algorithm. And you can also see that algorithm parameters have been passed in here as well. What would happen if there's a missing value? Well, use the previous value. What periodicity hint is there? Okay, and this in fact was the selection of monthly in the drop-down list, that for every 12 rows we commence a new cycle. There's also a property here by default that says, well, if we didn't specify the periodicity, we can control the degree to which it would look for a pattern. It's always good to specify the pattern if you know it, rather than have it attempt to find it for you. Having created the mining model, the next thing it does is it inserts rows into the model. Essentially, this performs a process. It takes the data from the spreadsheet, sends it to the model, the algorithm detects patterns, and then what we see is the querying of this data through 3 queries for each time series. This is what allowed it to produce the rows at the bottom of the table and to produce the chart. So this is just an interesting feature that provides you insight as to the communication taking place with the server. Now what I'm going to achieve in this demonstration is the creation of a forecast model. Here within the data mining section, I have the ability to forecast, and then the wizard guides me through the process. First of all, where is the data coming from? So it's of interest to note here that you don't necessarily have to mine data that is in the spreadsheet itself. With a predefined data source, you could write a query against, for example, the data warehouse. For this demo, keeping things very simple in this session, I'll continue to mine the data inside that table. Clicking Next, where is the timestamp? Yes, it is the month column. And the input columns that will perform the mining on should exclude month. In fact, I don't know why the wizard even defaults to include month. The 3 products will be included, and then next in the bottom left corner, I click parameters to configure the algorithm parameters for the time series algorithm. So the ones of interest here would be, first of all, the periodicity hint. The periodicity hint allows us to determine or tell the algorithm exactly how many rows it will encounter before a pattern or a cycle repeats. So I'm going to specify the value here as 12. The next one will be the forecast method. And the forecast method is allowing us to determine what algorithms are used. I mentioned earlier that analysis services in fact blends the result of two algorithms together, ARIMA and ARTXP. For this demonstration, I'm going to exclusively use the ARTXP, so we can take a closer look at the cross-prediction capabilities. Out of interest, if you wanted to control the blending, that is what the prediction smoothing is used for. By default, 0.5 says it uses a 50-50 blend of the two, but you can skew it one way or the other. This will only make sense if you're using the mixed forecast method. Here I'm using ARTXP, so this property or parameter has no bearing. With those two configurations, I click OK, return to Excel, and then click Next. It wants to know the name of the structure. Demo seems a perfectly good name, and then the name of the model within the structure. So just briefly, the way that analysis services works is that you can define a structure that defines the data that you're mining, and then associated to this structure could be one or more models that reuse it. In this case, I have a single model named demo within a structure named demo. And then the options allows me to browse the model. So there are visualizations that are provided with SQL Server data mining, and there is a visualization for the time series algorithm. It will automatically launch this visualization to allow me to explore the patterns that it has discovered. The enabled drill through is actually quite important. For the time series algorithm, you must always have this enabled. Drill through has different capabilities depending on the algorithm that you use. For the time series algorithm, it's actually critical because this is the way that it queries certain historic data for the purpose of your query. All right, so this must be enabled. Lastly, the use temporary model. I'll leave this off. That is the concept of the session mining. By saying that this is not a temporary model, this will be a persistent model that I could return to, reprocess, and continue to query. By clicking Finish, it communicates with the server, it creates the structure, the model, it uploads the data, and as a result, we see the browser window open to show the forecasting output. Okay, so there are in fact two visualizations. Here is just the time series visualization. I'm going to switch off the strawberry and vanilla. With a focus and an objective on forecasting chocolate, what I see here is the solid line representing the historic data and the dotted line representing the predicted values. Up here in the top, I'm able to increase the number of prediction steps. So every time I increase this, it issues a new query to the server requesting the prediction for the next steps. Let me bring this up to the next 24 steps, and you can see a definite trend here of growth and increasing sales over the year, and the peak continuing to take place in the middle of each year. The second tab provides the tree view visualization. Now, in fact, under the covers, ARTXP is using a decision tree, another algorithm provided with SQL Server, to do something. And let's take a look at what that is. I'm going to switch the tree to chocolate, and by hovering over the single node here, what you'll see in the tooltip is that there is a regression formula. All right, so in fact, the way that we predict chocolate is via this equation, that we can take minus 43.101, and then we will subtract from it vanilla of 12 months ago multiplied by 2.3.02, and then you'll see that vanilla of 24 months ago has an impact, and chocolate of 24 months had an impact, as did chocolate and strawberry 12 months ago. So it's quite extraordinary that what this algorithm was able to achieve was by looking at the other time series, it could see that there was some relationship, and it could surface that through this type of formula. And that's what the cross-prediction capability can achieve for you. Back to the chart representation, we can also turn on show deviations. And this is where we can answer the question about, well, just how reliable is this from a point of view of forecasting. By enabling this, what you will see is that you end up with these vertical bars. And the smaller the bar, or what can I say, the shorter the bar, the lower the standard deviation. And the lower the standard deviation, the more reliable the forecast is at this point. So it's of interest to note that the first 12-month cycle is a reasonable small deviation, but when we get into the next 12 months here, you'll see that the deviations are actually larger. And the reason for this should be obvious if you think about it, is that we saw in that equation that it was using chocolate of 12 months ago. So when you're predicting beyond 12 months in the future, then you're actually predicting based on predictions, and very, very quickly these models will become unstable. Our suggestion to you is that the forecasting, in particular with ARTXP, should be used for very short term, maybe the next 3, 6, at max 12 within a monthly cycle should be used. Beyond that, you're just predicting based on predictions, and that's like guesses based on guesses. All right, that's what the browser can achieve for us. Let me close the browser window. And the next thing that we could look at is, well, how could we query this and make use of the forecasting results on our own? So what I'm going to do is use the query capability here on the ribbon to issue a query based on the demo model. The number of predictions, I'm after the next 6, and then yes, I want to predict the chocolate. And where do I want those prediction results to go? The existing worksheet is fine. Let's position them here in this cell. And by clicking Finish, it runs a query and it brings the result back as a new Excel table. And my intention now is to append this data to my existing set that I used for prediction. So let me do this. In cell A38, I'm going to use a formula here that says just give me the date value of what you find in L2. Now it thinks that I'm adding a total to my table, so I'm going to tell Excel, no, this is a formula that should be inside the table. Now you'll notice the numeric values that are being returned. There is the prediction value, and then there's a standard deviation, which is our measure of reliability. And Excel, for some reason, thinks that these are text values, so I'm going to update these and convert them to a number. I'm not interested in vanilla and strawberry, so let me go ahead and delete those 2 columns. And then in column B, row 38, I'm going to say equals K2. And that introduces the forecast value. And then next, I want a measure of reliability. So let me bring in here standard deviation, and I'm going to create a new column for it and a low and a high. So the standard deviation will simply equal the value in L2, and then I'm going to use a formula here to determine the low value, and that will equal, if I go ahead and round the forecast value, and then I subtract from it 2 multiplied by the standard deviation, and I round this to 0 decimal places. It is this formula here that is going to give me the lower end of my plus or minus 95% confidence. All right, so I'm going to copy this also to the clipboard because I'm going to use it for the high. If I paste it in, and I change the minus to a plus. And so we'll see for this prediction, the lower end would be 747, the top end would be 827 with a 95% confidence. I'm going to remove the autofill here because it doesn't make sense for the past values. And then what I'm going to do is copy this entire row down to provide the 2, 3, 4, 5, 6 future steps into the future. There they are. Let me copy and paste as values. And there is a manual technique that I've used. I'm going to remove these query results to bring in prediction results and also determine a range of confidence. What could I do with this then? Well, this is a great opportunity to bring in Power View. This entire table, if I insert a Power View sheet, I'm going to create a new sheet, and let's represent the data consisting of historic data right through to future prediction values. Okay, by default it gives me a table. Let me resize this to fill the entire sheet. Here on the right hand side I'm going to remove standard deviation. It's not required. And then I'm going to switch this visualization across to a line chart. And there is a technique that we can use to determine here the blue is chocolate sales, and then we can see the high and the low values for the predictions. There's my demonstration of forecasting with the client tool add-in, certainly more involved but much more control and therefore power when it comes to defining my data and querying for prediction values. So in summary, with the Excel data mining add-ins, these are in fact Microsoft's first attempt to deliver forecasting to end users for information workers, analysts and data scientists. The data mining engine, importantly, is on premises. It will require that you have SQL Server 2008 or above and Business Intelligence or Enterprise editions. The table analysis tools delivers simple forecasting with few configuration options based on data within the spreadsheet. And yet the client tools add-in provides a much more extensive experience with full control to configure the algorithm parameters and to query and bring results back into Excel. The second topic, and one of recent interest, is that Power View in Office 365 has been extended to support self-service forecasting. It's available as a feature of the Office 365 Power BI suite. This means that you must have a subscription to Office 365 with the Power BI for the cloud delivery of Power BI analytics and reporting. It offers self-service forecasting experiences driven from a Power View report that is rendered in HTML5. Forecasting is easy in that you produce a line chart consisting of your time series. And once you publish this workbook with this Power View chart, you can then view it in the browser, switch to HTML5, and then, as I'll demonstrate shortly, you may interact with it to commence forecasting and other activities. Now the cool thing about this is the forecasting is all done immediately and the results are displayed back to you graphically within the same chart. This targets certainly the information worker. There's no need to understand all of the forecasting life cycle and the complexities about how to prepare data. It simply comes down to producing the right type of chart. Let me show you this one, and I'm cheating just a little bit. I found that it makes a lot more sense to pre-record this one so I can zoom in and focus on features of the animation and describe them to you. So let me narrate this demonstration. And so we start here with the use of an Excel workbook. Now in fact, the Excel workbook consists of this Power View chart, and I want to show you how this chart came about. Sitting inside the same Excel workbook, I have the sales over time Power View sheet. What I'm going to do is introduce from my sales table month and sales. I'm going to resize this, and I'm going to simply switch this across to a timeline or a line chart. Simple as that. You'll notice here in the bottom right corner in the report layout that sales is the value that we're plotting, and on the axis I have month. In Power View, this enables me to do things like cross-filter. If I filter here on frozen yogurt, I get to see sales by month for frozen yogurt. If I click on ice cream, I get to see the time series for ice cream. This workbook has then been saved and published to Power BI, and I jumped ahead, I'm sorry, and this is where this demo picks up. Here is the workbook having been published, and a user then would simply click on it to interact with the reports contained within the workbook. Now what I want you to notice in the bottom right corner is this special icon. By default, if you have Silverlight installed, it will use Silverlight to render the Power View report. However, you can click across to HTML5, which is in fact the requirement for forecasting. Re-rendering this sheet then as an HTML5 report, we can continue to interact with it by filtering on frozen yogurt. Here we see there's $1.9 million worth of sales, and we see that the forecast updates, or rather the time series updates, to show us. And if we switch across to ice cream sales, of which we have 2.8 million, we get to see the time series for it. Now, when you hover over data points, you can see month by month the sales that have been achieved. And you'll notice also on the far right corner, or the right side, that there is this bar that allows the forecasting. And with a single click, it has produced this forecast for the next 12 points. And here we see the projected values by month. To continue to click keeps adding to the forecast. So here a number of clicks produce a forecast right through into 2015. And what it's doing is it's using the data in the chart to detect a pattern and feedback immediately by extending the chart. Here we see the ability to control seasonality. It will auto-detect it usually, but if it doesn't get it right, you can choose it. The confidence interval, when you select it, here we see one standard deviation is shown to us in the chart through a shaded area. So we can see that 68% of expected values would be within this area and 95% within this wider area. I'm going to turn the feature off to demonstrate another couple of capabilities. So in addition to forecasting, we have the ability to hindcast. What that means is we can use past values. See, the point here is let's use past values up until 2012 to produce a forecast and show us that what would have happened if we had a forecast. The dark blue here is the actual values, the forecast is in light blue. The other thing is we can correct data anomalies. By dragging a value down here, I'm correcting this peak. And what it will do is recompute the pattern and forecast based on the adjusted values. With a double click, I can restore it to its original value. And what I've demonstrated to you here is the ease and simplicity of forecasting, hindcasting, anomaly correction, and also the testing of confidence with standard deviation. Now, by switching across to frozen yogurt now, notice the way that the chart and the forecasts update, this time for a different product. This is the capability now available to us by using Power BI and the Office 365 site. Let's dig into this a little more deeply. The PowerView forecasting capabilities are the result of a cross-team collaboration. The design explicitly is about simplicity, intuitiveness, should also be fun, exciting, and beautiful. The integration is achieved through Excel and PowerView. On the desktop, you will produce a line chart, and then you will publish this in order for it to work. The forecasting will only work through the Power BI service with HTML5 rendering. This is not a desktop experience. With a discussion on the algorithm, it has been configured to automatically detect seasonality. Now that can be overridden, as you had seen in the right-hand panel, but if your data has a very clear cycle, it will detect this automatically and use it to train the model. It's all been configured around low latency response. As you see there, a request for a forecast, a hindcast, or a change of a historic value should result in a new forecast within seconds. The details of how this works: it is not using analysis services as the Excel add-ins does. It uses a newer algorithm named exponential smoothing. It's been enhanced with robust capabilities. So I'm not going to go into the deep details about how it achieves what it does, because for an information worker, they're more concerned that it just does its job correctly and it does it reliably. But some of the features are that it does this based on a small set of data with auto detection of seasonality and with a fast training and query response time so that it can work as an interactive experience within PowerView. The requirements to make this work: first of all, the subscription and licensing. You will need Excel on the desktop to develop a workbook consisting of the PowerView report that meets that requirement of a line chart. You will also need the ability to publish this to Power BI. That will require Office 365 and a Power BI license to host these workbooks in the cloud. The data characteristics: you will need a uniformly increasing date time or integer x-axis value. The time increments, if you're using date time, can be day, week, month, or year. and the target value, as is sales in this case, must be numerical. The PowerView report layout must consist of a line chart. You cannot forecast anything else. And currently a multi-line categorical chart is not supported. For example, if I had the 3 product flavors of vanilla, strawberry, chocolate, there would be no forecasting capability of those at the same time, but you could use the technique as was used in this demonstration to filter a line chart to produce a single line, and then it will support the forecasting capability. The client application simply needs an HTML5 supporting browser. This is also a capability that can be delivered through the mobile Power BI app for Windows 8 with touch devices. So in summary for the PowerView forecasting, information workers can easily visualize time series data into the future. They can understand what it could be. They could also understand how data is trending. Forecasts can be compared to actual results with a hindcast. And the hindcast can also convey an understanding of how past events have impacted on what was expected. What-if analysis can be achieved through the correction of data anomalies and without the need to change the actual source data. It's just a matter of dragging values to reset them. In summary then, use forecasts to understand what is likely to happen. So let's rely on good data science rather than gut instincts or guesses or the insights of an octopus. We can deliver forecasting capabilities direct to information workers with simple and responsive experiences. And we'll leave it to you to choose the tool that fits best. Is it the Excel data mining add-ins, or would it be the PowerView in Office 365? To help you make that decision, let's perform a comparison. Excel data mining add-ins. These are supported directly on worksheet data. We can analyze worksheet data. There is support for the full data mining cycle, and this will work for Excel 2010 and Excel 2013. This is a free add-in. Download it today, install it. It will require the cooperation with some administrator on your network to enable you to connect to an on-premises analysis services multi-dimensional instance, and our awareness is that this uses the Microsoft time series algorithms to perform forecasting. In contrast with PowerView in Office 365, this is the newer and intuitive self-service analysis via the Power BI site. It supports auto-seasonality detection, hindcasting, and what-if analysis. It does require Office 2013 or Office 365 to develop the report. For those that are consuming it, it will require the ability to connect and authenticate against a Power BI site. That will require Office 365 Power BI license. And it uses the novel and enhanced exponential smoothing algorithms with built-in seasonality detection. So I think the decision to go one way or the other depends on the tools that you're using, the licenses that you have available, and the capabilities. The more control, obviously, you'd be looking at the client tools in Excel. For those that want simplistic forecasting, you have the on-premises approach with the table analysis tools, or the newer approach with HTML5 interaction in PowerView with Office 365. Let's then wrap up with some resources that could help you on your journey to explore forecasting in more detail. SQL Server Predictive Analytics website is Microsoft's site to describe their current product offerings. It includes links to related documents, related sites, and community resources. The MSDN Analysis Services data mining documentation will allow you to go deeper into documentation on SQL Server data mining. And then the add-ins are available at this link here, or simply by going to Microsoft.com, searching for data mining add-ins, you'll find them very quickly. When it comes to a publication and a book on data mining, there really is only one consideration, and that is the Data Mining for SQL Server 2008. Don't be misguided by the older version of SQL Server. There have been very few advancements to data mining since its first release in 2005, so what this book has to say is still terribly current to SQL Server 2012 and 2014. What I think is particularly good about this book is that it doesn't assume that you have background in data mining. Therefore, opening chapters will introduce data mining and the application of it and where it could fit to solve certain business problems. And then it dedicates a chapter to the major algorithms, of which there are 12 delivered with SQL Server data mining. The one of focus for us here in this session was the Microsoft time series. So there's an entire chapter that talks about how the algorithm works, how to produce a solution, and how to tune and optimize that model for reliability. The latter chapters of interest include how to embed and how to integrate data mining with other SQL Server products. So I think this is an excellent read, especially if you're new to data mining and you're interested to explore what you could achieve with it. To know more about the recent forecasting capability added to Power BI for Office 365, there's a great blog entry here. And if you're not convinced by anything I have to say here about good data science with Microsoft BI, well, I can refer you to Paul the Octopus, and Wikipedia have a great article about him and his amazing capability with 100% accuracy, don't ask me how, to predict the outcome of the World Cup some 4 years ago. That's the content of this session. We'll now open up with Aaron to find if there are any questions that have been arisen during this session. Aaron, what did you find?
All right. Well, besides the normal, will the slides be available and will there be a recording?
Absolutely.
Yes.
This recording will be available through the PASS site, and we would encourage you to share the link wide and far for those that you might think would benefit from the information in this session.
All right, so after that we've got, can we get this ice cream examples to try this ourselves?
Can we get the ice cream samples? Yes, you can. So the last demo that I did with PowerView was in fact using the sample workbook that comes with the Office 365 Power BI site trial. So now would be a great time to let people know that if you want to explore that PowerView capability and you're not currently with Office 365 or with the Power BI subscription, no problem. PowerBI.com. You can remember that. PowerBI.com allows you to register for a free 30-day trial. And what that 30-day trial will give you is 25 licenses for Office 365. That'll allow you to download it on the desktop and explore with it. You could create your own forecasting solution with PowerView. It gives you the Power BI site, so you can publish your own workbook up there and explore your own data. Or it gives you the ice cream sample, which is in fact the answer for this question. That sample is provided in the Power BI trial site, and then you can work with it direct. You could download the workbook to the desktop, you could look at the data, you could look at the reports, or simply interact with it in the Power BI site with the HTML5 viewer.
All right, next up, can I show Power BI spreadsheet forecasting directly from my own SharePoint Office 365 website, assuming I have a Power BI license?
Could you repeat that question? I thought it was going in one direction, but it went in a different direction.
Can I show Power BI spreadsheet forecasting directly from my own Office, SharePoint Office 365 website, assuming I have a Power BI license?
Yeah, the answer to that one currently is no. So there's no embedding story for this. You'd have to interact with it direct from the Power BI site by using your web browser. The only other approach is via the mobile BI app. So no embedding story like with a web part or anything at this stage anyway.
Okay. Similar question, can Office 365 Power View report be built, updated from an on-premise SQL server?
So we're talking about building, and so I think where the question's going is that you want to produce a workbook on premises that uses SQL Server data, expresses this as a line chart that we can then publish this workbook and report to the Power BI site and then interact with the forecasting. Do you think that's what they're asking, Aaron?
I'd agree with that. Yeah, that build it in-house and then post it up on Office 365 to be consumed.
And the answer is absolutely yes, so I'm glad this question comes up. So it doesn't matter where your data comes from, providing that you get it into the workbook. And then once it's in the workbook data model, then you can produce a Power View report on top of it. So Power Pivot natively supports access to all popular database products, to OData feeds, to analysis services, to text documents like CSV. What makes this question interesting is that what would happen if we wanted to forecast based on current data? Now, the fact is that Power BI supports refresh to internet sources and to on-premises sources like SQL Server. So a scenario could play out here that you produce a forecasting solution on the desktop using SQL Server data, you publish the workbook to the cloud, you enable data refresh to on-premises SQL Server data, And this means you can continue to use that workbook based on current data and continue to produce new forecasts based on the latest data you have on premises.
All right.
It's a beautiful Power BI scenario, bringing the worlds together, SQL Server on premises right through to forecasting in the cloud.
Perfect. All right. Trying to pick which to go to next. Let's see. Are there any multiple regression tools in MSBI to allow use with analysis cubes?
So I think this is a question about using a cube as a data source for mining. And so SQL Server data mining does support this. In fact, if you create an analysis services project in Business Intelligence Development Studio, we typically use these projects to create cubes or data mining solutions. Providing that the cube is within the same project, you can build data mining solutions on top. So this would mean we have a cube and then we can produce a time series forecast based on the cube data. That's the only condition, is that they must reside in the same database, but yes, the answer is it can be done. This is not an IW self-service approach though.
Right, right.
Oh, can I extend to that? So if you're going to use Power BI, basically there are other techniques you can use in Excel. Excel can query a cube via a pivot table or cube functions. If you can get data from the cube into the spreadsheet, then you can make it into an Excel table, and then you can use the add-ins to perform the mining. So there's an indirect way that an IW might achieve querying the cube into the spreadsheet to then perform mining activities.
Gotcha. There we go. All right. Looks like only 2-3 more questions. Is it easy to group data from months to quarters to get more reliable forecasts?
To group data from months to quarters to get more reliable forecasts. Well, it could be a technique, and I'd probably prefer that you did it from days to months. You know, months to quarters, that would mean that within an annual cycle you'd only have 4 data points, and I don't believe there'd be enough there to provide a stable pattern. So let's perhaps, without changing the question, use an example of days to months. Yes, this is what data models do particularly well, is that they do aggregation. So to bring daily ice cream sales and to aggregate them up to a month level would be a much better approach for mining and a forecasting activity. Instead of having 365 data points, and there could be some erratic behavior with weekends and public holidays and weather patterns and so on, what you're going to find is that you'll smooth out the data. But you don't want to smooth it out so much that we've only got 4 data points, but if you want to smooth 365 data points to 12 data points, I think that would be a good idea. And don't take my word for it. Try it for yourself. What result do I get if I bring in 365 days of value, or I bring it to 12, or I bring it to 4? And what reliability can I measure? And that would help you decide, based on your own data, what would be the most suitable approach to take.
All right, and looks like this might be the last one. Is it possible to, and I think you've already maybe touched on this in the presentation, but I'll let you decide, is it possible to factor in adjusters which can affect the forecast in order to make it more accurate? I think that was that update.
Yeah, totally. We've addressed that in several ways. So you've got the ability in Excel to manipulate the data directly before it's mined, or in the Power View experience, just a drag and drop allows you to modify values to reforecast based on, you know, cleaner, more appropriate data.
Oh, and we did get one last question. Do users of Power View forecasting need Office 365 subscription?
Yes. So whether you're producing a solution and publishing it, or you're simply a consumer, then you must have the same license, which is Office 365 Power BI license. There is no difference between one that is contributing a solution and one that is simply connecting to and interacting with the solution.
Okay. All right. Well, that's all we've got for questions here, Peter.
That's all the questions. I'm glad that we could address most of those, or all of them, I think. We hope that you liked what you heard. So I will be attending the PASS Summit in the first week of November. I have, in fact, 5 sessions now. Here are 3. The first is on the Tuesday, I'll be delivering a full-day pre-conference session entitled Superhero Power BI. This is a session that's aimed at a wide audience to describe to them and demonstrate end-to-end how Power BI can be used to solve simple and some complex business problems. This will go into the background about what is self-service analytics, why do we have a need for it, how can the business support it, and then based on that discussion we'll introduce the 4 Power BI add-ins on the desktop with Power Pivot, Power Query, Power View, Power Map to produce an end-to-end solution, and then the day wraps up by describing the Power BI site with its capabilities, the publication of the demonstration workbook, and then right through to automatic on-premises data refresh. How can this be configured and managed? This is an end-to-end day that will allow you to understand the latest and greatest offerings for self-service analytics from Microsoft. A couple of other sessions I'll be presenting on how to prepare a Power BI workbook for publication. What do you need to do to fully exploit the capabilities available to us in the Power BI sites in the cloud? And also, not so related, but for corporate business intelligence, here's an end-to-end topic on master data services. A couple of other events that will take place. I will be doing 2 instructor-led labs that will allow you to be led by me as the administrator of a Power BI site, and you will follow by configuring, publishing, and enabling automatic data refresh. There are 2 of those sessions scheduled for this week also. That's pretty much what I'll be contributing, shoulder to shoulder with many, many other professionals that have got amazing stories and information to share with you. Aaron.
Yep. And once again, I just want to remind everyone, use discount code 24HOP14 when you